Welcome, everyone. So you've been thinking about these two wave pulses, which are moving towards each other. You can see that they consist of a large pulse over on the left, which is indicated with the blue small dashes. And then we've also got a small pulse over on the right, which is indicated by the big red dashes. That's that part of the string. And these two waves are moving towards each other. And we want to figure out what happens to the entire string, which is what's shown in black, as the two wave pulses approach. So you've had a chance to predict what you think is going to happen. We're going to go ahead and observe this and see exactly what happens. Now, this will keep looping so we can examine it. But what you will notice is that the pulses start out with the big one on the left and the small one on the right, and they end with the small one on the left and the big one on the right, which means that the two pulses are traveling through each other. Once the pulses have moved past each other, it looks like they are not affected by the other pulse. So the shape and the height and all of the features of each wave pulse seem to stay the same, but in the region where they come to overlap, the two pulses seem to add together in some way. And you can see the red and blue pulses shown in the dashed lines. If you add those two waves together, what you will get is the resulting shape of the string as a whole. This concept is known as wave superposition. And there are a few rules that you will use when you're adding together waves or wave pulses. And those rules are that both waves are going to influence the final shape of the string or the spring or any other kind of wave that you end up encountering. And that the total displacement of the string can be determined by adding the displacements caused by each wave individually, and that this addition, this superposition, has to be done separately at every point along the string. So you can't just, for example, add together the peaks of the waves and be done. You have to look at everywhere along the string, find the displacement of the first pulse, the displacement of the second pulse, add them together, and that gives you the resulting displacement. Now, displacements can be positive or negative in the case of a wave on a string. So you can get that waves will either add up and make bigger shapes on the spring, or that they'll end up canceling out and get smaller shapes on the spring.